Welcome to the class. Today we'll be taking dimensional analysis in Physics 101. In Physics 101. So in dimensional analysis. Now, before we can do this, we need to know that we have first of all, we all know that we have fundamental unit and derived unit. We know that the fundamental unit, these are the units we use to get our derived unit. And the common ones we have is what we have: mass, we have our mass, we have our length, we have our we have our temperature, we have our time, we also have our current. And the basic unit for each, for our mass, we know our mass is measured in what? In kg. That is the standard. In length is measured in what? Meter. Temperature is measured in what? Kelvin. Time is also measured in what? Seconds. And current in what? Ampere. And each of these has its own dimension. For mass, our dimension is what? It's a big M. For what? Length is what? We have our L. For temperature, we have our what? Theta. And for what? Time, we have what? It's measured in big T. And our current is given in what? You either use an I or maybe you can use A too. It's also correct. Now, this dimension analysis, we use it to what? To check correctness of what? Formula. We also use it to what? Derive some formulas. With time, you get to know that. And in this case, the first one we want to use to prove this is, let's use our force, which is a very common formula, which is what? Force equals to what? Mass times acceleration. I know for our force, mass is measured in what? The unit for mass is what? Kg. And our unit for what? Acceleration, which is what? Meter per second square, which is meter per second square. We already know that from our previous classes. Now, our kg, which is in the dimension for kg, we know is what? M times what? Our dimension for meter is also is what? L. And the dimension for second is what? T minus 2. So when we merge this together, our force will give us what? MLT minus 2. Very easy. So that is the dimension for force. Also, another common one we know is what? Let's try for that of pressure. Pressure is equals to what? Force over what? Area. Since we already gotten our force, we don't need to go over the step again. But if you have not gotten before, you can still do it. So our force, the dimension for force is what? MLT minus 2 over. Now area gives what? Area is what? Length times breadth. Length times breadth. So that means our area, both our length and both our breadth, are all measured in what? In meters. So we can also say this MLT, you can also say it's over over L square, which is what? The dimension for what? For meters. That's length. So we can say MLT minus 2 over what? LT. If you take this mathematically up, it's going to look like this. MM plus 1 L minus 2 over what? L minus 2 times what? T. So now this, we cancel out this, so that we are going to have M minus 1 T minus 2. That is an easy dimension for what? Pressure. Very simple, very simple. Let's also try one extra. Let's try something. Work done. Work done is equal to what? Force times what? Distance. Our force is what? As usual, is what? MLT minus 2 times distance is what? It's in what? In length. It's a length, that which is meters, which is, let's say, distance what? L. So we're going to add them up. That's what? L becomes what? 2. 1 plus 1. And this is what? Minus 2. So this is the dimension for work done. So this is very easy, very easy, very easy. Thank you for watching.